Welcome back to another episode of Learning Derivatives, where I will explain logarithms and how to use them in the product rule using Lagrange's notation. So, I will explain this. First we have a function, and that equals log to the base a x, a being a number, and the derivative of that function is 1 over x multiplied by ln of a. Basically means log to the base of a number, x, when you derive it you get 1 over x multiplied by natural log of that number, of the base. And here's just the product rule. We have hx equals fx multiplied by gx. The derivative is derivative of fx multiplied by gx plus fx multiplied by the derivative of gx. So let's do an example. Get right into it. Example 1. Say we have hx equals log to the base of 5x multiplied by 7x to the power of 5. We have our first function, and it's multiplied to a second function, therefore we use the product rule. Let's label these out. We'll call fx log to the base of 5x, and we'll call gx 7x to the power of 5. If you write out the first derivative following the product rule, you get you get derivative of fx multiplied by gx plus fx multiplied by the derivative of gx. That was poorly done, sorry, but basically we need to find the derivative of fx and the derivative of gx. The derivative, if fx is log to the base of 5x, then the derivative is 1 over x ln 5. Just like before, you have a log to the base of a number x. When you derive it, you get 1 over x ln of that base, which in this case is 5. If gx is 7x to the power of 5, the derivative of gx is 35x to the power of 4. If we fill this in, f dash x, 1 over x ln 5, multiply that to gx, which is 7x to the power of 5, add that to fx, which is log 5x, and multiply that to the derivative of gx, which is 35x to the power of 4. To rearrange this and make it look neater, we'll bring the 7x to the power of 5 on top of the x ln 5 and add that to, we'll just bring the 35x to the power of 4 at the front of log to the base 5x. Now I'm going to cancel this off. Because I have an x to the power of 5 over an x, we can take 1 off the power and make it x to the power of 4 and get rid of the x at the bottom altogether. So if we rewrite this, we get 7x to the power of 4 over ln 5 plus 35x to the power of 4 multiplied by log to the base of 5x. And that is the first derivative of this function up here. may look a lot more complicated than it is. It's just practice and just using rules and laws and whatnot. But let's do another example. Well, say example 2, hx equals 10x multiplied by log to the base of 2x. We have our first function, and it's multiplied by another function, second function. So we can use the product rule to solve this, which we will. Let's label fx as 10x, and let's label gx as log to the base of 2x. The derivative is f dash x multiplied by gx plus fx multiplied by g dash of x. So the derivative of the first function multiplied by the second function plus the first function multiplied by the derivative of the second function. We need to find the derivative of both functions in order to complete this. The derivative of fx, if fx is tan x, then the derivative is sec squared of x. That's just what it is. It's probably in the back of your math textbook if you didn't know that, or if you don't have a textbook, it's in the back of most calculus math textbooks, and if you want to Google it, doesn't matter. If gx is log to the base of 2x, then the derivative of gx is 1 over x ln 2. That's because we're just like before, you have log to the base of a number x. When you derive it, you get 1 over x multiplied by the natural log of that number, or the base. And if we fill this in, derivative of hx, the derivative of fx is sec squared x multiplied by gx, which is log to the base of 2x plus fx, which is tan x, multiplied by the derivative of gx, which is 1 over x ln 2. And simplifying it, there's not simplifying it at all, you just rearrange it. We'll leave the front the same, sec squared x multiplied by log to the base of 2x plus tan x over x ln 2. All I did here was just multiply the tan x on top of the fraction, because I can, because there's a multiplication, and that's just what it looks like. That's just it for the derivative. This here is the derivative of that. I didn't really do anything difficult, I just followed rules that I know that are in the back in math textbooks, and if you've watched the playlist that I put up on learning derivatives, you should know all these rules just about by now anyway. But I'll stop rambling and put up another example. Let's say hx equals log to the base of 4x multiplied by e to the power of x. Again, we have our first function, and we have a second function that is multiplied to that first function. I'm trying to explain it differently in case some people don't understand the concept, but you have one function and you're multiplying it by another function, and you can use the product rule to solve it. So, because they're lined up nice and neat, we'll label them as such. We'll label fx as log to the base of 4x, and we'll label gx as e to the x. That way, when we write out the formula, which is for the first derivative, which is f dash x multiplied by gx plus fx multiplied by g dash of x, well, we already have them labeled, so it's much easier to work with. We need to find the derivative of fx, and we need to find the derivative of gx. If log to the base of 4x is fx, then the derivative is 1 over x ln 4. And if gx is e to the power of x, then the derivative is e to the power of x. That's just how e's work. They're a funny number. And having e to the power of x, when you derive it, you end up with e to the power of x. That's just how it works. I won't dwell on it too much. If we were to fill this in, derivative of fx is 1 over x ln 4 multiplied by gx, which is e to the power of x, plus fx, which is log to the base of 4x, and we're multiplying it by the derivative of gx, which is e to the power of x. Because we have an e to the power of x multiplied to something on either side of the addition sign, we can essentially factor it out. Because it's multiplied to that, and e to the x is multiplied to that, we can essentially factor it out. That just means have e to the x bracket 1 over x ln 4 plus log to the base of 4x. All that means is if we were to expand these brackets, we would get that. So this is just a neater version of it. I hope this video helped. Thanks for watching, and I hope you have a good day.